All right, let's talk about writing and solving compound inequalities. I didn't mean to do that. Here we go. A number Q is at least -2 and less than 6. Okay, so Q is also less than 6. So first of all, I just want to point out that I have brought my cheat sheet. So if you're like, is at least, that we know is at least right there, and it's greater than or equal to, right? Okay, great. I'm okay with this answer. The probably more appropriate way to write this answer is like this. Was supposed to use a Q, but I don't care. I'm done. A number T is not less than. T is not less than. No. It's greater than 4 or fewer than -1. Let's see. Fewer is just less than. And we're done because an or is written like that. It's not combinable like that one is combinable. A number G is more than 2 or that G is less than 0. Easy peasy. A number D is less than or equal to 2 and greater than or equal to -2. Greater than or equal to -2. Now, you might be thinking, wait a second. You kind of wrote those separately earlier, and you're right. I did write them separately earlier. If you were to read this one from right here over, D is being eaten by that, is being eaten. So D must be greater than -2. So I've now officially written this in order. One thing I mentioned on the notes that I'll mention here is you want to write these smaller number to bigger number. And you'll notice that when it said this, a number D is less than or equal to 2, I was like, the way this is going, it looks like this right here. So I'll bet that this is the bigger number without even having read the rest of the sentence. And then when I saw this, I thought, okay, well, let me see if it follows this flow because of the and, because we were kind of expecting it to, all right? And if you don't know what I mean, then just write these separately, then combine them, you'll get that right there. A number M is not less than, so it must be greater than -1, or that same number M is less than or equal to -5 1/3. Again, that's an or, so I guess I should write the word or. I did it there and there, I just forgot to do it on the number 5. Solve them, graph them, let's go. By the way, I checked, we're supposed to be graphing these things up here, so let's do a little rapid fire graphing. What I'm going to do is erase this guy and throw down the number line, -2, 0, 6, and we got a filled in circle, we have an open circle, and it is an and. Next one is this right here. We're going to do 0, -1, and 4, open circle. T is the numbers that are less than -1 and that greater than 4. That's what an or looks like. The next one, I'll just scooch over here, why not? We got a number G is greater than 2. So open dot. G is the numbers that are less than 0. G is the numbers that are greater than 2. And that's what an or looks like, so we're good to go. Next, between that and that, -2, 2, 0. We have a closed dot on -2. We have a closed dot on 2. And it's in between because that's what an and looks like. And then the last one here before we get to the problem we were really on, 0, -1, -5 1/3. Close dot, open dot. It's an or. These are the numbers that are less than or equal to -5/3. These are the numbers that are greater than -1. All right, let's do this one now. Solve the inequality, graph the solution. You have the choice of separating this out to looking like this. You have the choice to do that. I don't like doing that, but you have the choice to do that. And really, I guess I shouldn't say I don't like it, and that's why I never do it. I guess it's really just situational in which I might do it. I say that because I know coming up in the future that one of these we're going to kind of prove that it's ugly. Well, you really won't need much help proving it's ugly. It's ugly, and we'll do it separately so that we'll go, oh, okay, that's it. So here we go. We got 3 sides. I'm going to subtract 10. Okay. And I'm going to divide by -3. That flips this inequality. That flips this inequality. And there we go. And so, by the way, I noticed early on that these inequality symbols, these greater than symbols, we usually don't write it like this, right? I told you that the smaller number goes over here, -8's the smaller number here, right? But after we do all this algebra, after we do all this solving, it's perfect, right? So now let's graph it. Here's 4, here's 6. I just kind of made that coincidentally cool like that. I'm going to do a closed dot on 4, a closed dot on 6, and it's the numbers in between. Number 8. It's an OR. Cool. Subtract 2, subtract 2. I get Q is, okay, well, hang on. So they have it written like this. I don't really like writing it like that. I prefer to put my variable on the left. It's just a preference thing. You do you. I'm going to divide over here by 5, and I get Q is greater than or equal to -3. So there's -15, there's -3, there's 0. Q is the numbers that are less than -15. And here are the numbers, that's it filled in, that are greater than or equal to -3. And that's what an OR should look like. Number 10. Well, you know what? I'm going to graph this, solve it and graph it all combined. And the first thing I'm going to do is multiply everything by 3. And when I say everything, I kind of choose my words that way because this little segment right here, this is just going to cancel the 3's, the 3 and the 1/3. So I get -18 is less than 6y plus 12 is less than, oh, I zoomed out somehow, 54, no, 42, yeah. And then I'm going to subtract 12, -20. I'm going to subtract 12 to get 30. I'm going to divide by 6 to get, I think this is like 3.5, -3.5. And this is 5, okay? Let me double check the answers so I don't have to do math. Double checking my answers. No, I'm wrong. It's not that. How did I screw that up? Oh, because 18 minus 12 is not 20, it's 30. So when you divide that, you get -5. So here, let me stop being lazy. Actually, that was still kind of lazy, but there you go. Here's our graph. Here's 0. Here's -5. Here's 5. Open circles. This is an and after all. I will be shading in between them. And if you're like, hey, how do I know if I'm shading in between them or not? How can I really be confident that an and is going to look like this? Well, just go ahead and do what you need to do. G is the numbers that are bigger than -5. And if you're like, wait, but that's a less than symbol, I know. -5 is less than these numbers. So -5 is smaller than these numbers, and you'd shade that way. I just happen to read it backwards. Again, it's a preference thing. I like to write mine like this because I prefer to read them like this. And then right here, G is less than or equal to 5. G is the numbers that are smaller than 5. So there would be an overlapping section right here and graphs like that and look like that. Subtract 8 from all sides Divide by 2 on all sides. This one's not that crazy, huh? -6, 0, 5. Open, shade in the middle, because that's what an and looks like, and because that's what that says. 15 is an or. I'm going to add 8 to get 23 is less than -v. Multiplying by -1, I get that -23 is greater than v. And over here, subtract 4 and divide by 3, like that. Let's graph it. We got 0, we got 2, we got -23. Open circle, -23 is bigger than these numbers. Well, so that means we're going this way with it, right? And if you're like, I don't get it, I don't like to write it like this either. I'd rather flip it around. So v is now less than -23, and that just works better for me. And then the other one, v is greater than or equal to -2. So we have a filled in dot here, and it's greater than that, right? And believe it or not, that's our answer, because that's what an or looks like. Okay, this is a little scarier looking, but it's just a few more steps. An or, so we're going to do this one way, we're going to do this one the other way. Here's what I'm going to do. I'm going to divide that side by 6 and that side by 6 to get 7 is less than 3 minus k. I'm going to subtract 3. I'm going to multiply by -1. And I have to flip my inequality. Over here on the right, I'm going to multiply by 2. And I get 20. And then I get to add 8. And then I divide by 14. Almost said 2 because the answer is 2. And now let's get our graph on zeros in the middle. I mean, not in the middle. You get the idea. Open dot on that. And again, I don't love to read it like this. I prefer to rewrite it. So let's rewrite it real quick. K is less than -4. So we're going to shade less than -4. And then over here, this is all good. It's a filled in dot. K is greater than or equal to 2. It's all of the numbers that are bigger than 2. 12 through 15, solving graph. Cool. All right. We've got just kind of bigger, uglier looking ors. I'm going to move my variables to the left because I feel like it. So I'm going to go ahead and write out my steps. One thing that math people love to do is not show their work, right? But I'm going to do that because I don't want to miss details. And you guys know I never make mistakes. So let's go. Subtract 12, subtract 12, subtract 5, subtract 5. Divide by -4, and we get W is greater than -2. And over here, I'm going to subtract 9 to get -6 is greater than -3/4 W. I'm going to multiply by -4/3. And what we end up getting, let me do my little canceling right here. That's now -2, is we get W on the right, yeah, is now greater than, I mean, it's technically less than, it just flipped, okay? And then we're going to get +8 on the left. All right, so let's see what this graph looks like. We have 0-ish, -2-ish, 8-ish. We have an open dot on -2, and W is greater than -2, okay? And this guy, remember, I like to write them the other way, which is also why I pronounced this, or described this as W is greater than 8 earlier. So we got an open dot on 8, and we shade to the right, because those are the numbers that are greater than 8, right? And so our answer is just technically this, because it includes this, right? If I were to ask you to give me a number that's greater than -2 or greater than 8, okay, well, this is going to include some answers that this doesn't. And since we're doing an or, it's just has to fit one of them. Remember my example, stupid example of If I ask you for a peanut butter and jelly, you're expecting peanut butter and jelly on your sandwich. If I ask you for peanut butter or ham, as long as you show up with peanut butter or ham, you have made me what I asked for, even though what I asked for is really strange, okay? Next, just another kind of complicated looking one. So 3D, I subtract 17 from both sides, and I get -6. Divide by 3. Thank you. This one was not that complicated, but over here it is. I'm going to subtract 4, and I get, that goes away. On the right, I get 20, and then I'm going to add 3D, negative D is less than 20, but now I'm going to multiply by -1 or divide by -1, doesn't really matter. D is now greater than -20. Okay, let's get our graph on. We got 0, we got -2, we got -20. The pink graph is a filled-in circle shaded to the left. The green one is an open circle shaded to the right. And because this is an OR, our answer is all real numbers because we shade everything here. Give me a number that's greater than 2. It works. Give me a number that's less than -2. It works. And then they do overlap. Usually an OR, like I've said in the past, kind of looks like this. It's shaded, I'm here before or after school, but it works for the whole thing. So it's all real numbers. Okay. Let me zoom out to erase that real quick. Let's zoom back in. Let's get this going. Come on, Zoomy. Whoa. All right. Number 13. Kind of a complicated looking and. Interesting that it says and. That doesn't mean that if I add 15 here that I have to add 15 here. Nope. Not going to do that. This word basically says, hey, we're going to separate you guys. And you're going to be work on your own problems, okay? So plus 15 cancels. We get -2. I'm going to subtract 3t. And I get -t is less than -2. That's really t is greater than +2 now. And then this one, we're going to add 13. And that's it. So, boom, done. Let's go 0, -6, and 2. Open dot, shade to the left, because that's all the numbers less than -6. Open dot, shade to the right, because that's all the numbers greater than 2. That's usually what an OR looks like. So I think we have a problem. This is a no solution because they don't overlap. And remember, this is peanut butter and jelly. There's supposed to be an and here. There's supposed to be, you got to bring me both. I have to satisfy both of those, and I don't. Number 15. Okay, now we do have a long combined and, like I was kind of talking about. And then this is the one that I said, you have the option to doing them separately. This is the one that I'm like, yeah, it's kind of funky. So let's do it separately. But just for fun, why don't I, actually here, let's do this. I'm going to go ahead and just start solving it like I would like to, right? I'm going to subtract 6 because I want my variables to be alone in the middle. But spoiler alert, I've got variables everywhere, so that's why I mentioned this one's kind of funky, so I'm going to have to do it a little differently. So we get 4x plus 3 is less than -9x, which is less than 4x minus 3. Okay. Well, okay, I want to move all my variables to the middle, so I'm going to subtract 4x. Gone. And then I get 3 is less than -13x, which is less than -3. Well, that's interesting. Usually, like I said, with an and, smaller number, bigger number. But, when we divide by -13, we're going to end up getting -3/13. Flip the inequality. I didn't. I said it, but I didn't do it. Flip the inequality. X, flip the inequality. Positive 3/13. Wait a second. We can't do that, right? Like, there are no numbers that are less than this one and greater than this one, right? So let me show you what I'm saying. If I were to try and graph this, we have 0, we have negative 3/13, we have 3/13. And just like our graph over here, where I was like, oh, I'm sorry, just like our graph up here where I said, nope, no real numbers, or no solution, no real numbers. That's fun. If I graph this one, I'm graphing less than, because this number is greater than x. I did that a little out of order, so for my undoings. And then this one over here is x is greater than, so here it is. And there's no overlap, so we have no solution. Tuxedo rental shop rents tuxedos with sleeve lengths from 20 to 40 inches. Okay, so just right away, I'm going to kind of do this. I'm going to, I don't know if I really need to do this, but there's sleeves 20 to 40. Okay. The shop says the length of the sleeves should be about 1.2 times a person's arm length. That's probably going to be important. Write and solve a compound inequality that represents the arm length of people for which the shop does not provide tuxedos. Not. That's very important. They even italicized it. So let's see. Let me read that one more time. Write and solve a compound inequality that represents the arm lengths of people for which the shop does not provide tuxedos. How about this? We have an and here, but now, and what this would look like is it's kind of like, hey, our shop has tuxedos for, let me color it, for these people. And that's how an and is graphed. So we are now going to communicate the or portion of the graph, or just the this part, and that would be an or. So let's see, you've got 1.2 times your sleeve length or arm length needs to be less than 20. And if you're like, wait, that means they're not going to get one. You're right, because we're doing the ones that would not work. So 1.25s is less than 20, or 1.2s is greater than 40. And then we can actually solve for both of these. So you would just do 20 divided by 1.2. In fact, here, I'm going to kind of zoom in so that we can not have to rewrite this. 1.2, divide that by 1.2, divide that by 1.2. And so this guy, his sleeve has got to be less than this one. This guy, his sleeve's got to be greater. And remember, this is an or. The top one, let's see, the right color, 16.6 repeating. And the bottom one is 33 and, ooh, the wrong color, but that's the idea. Okay. Write a real life story that can be modeled by the graph. Jeff buys packages of strawberries 2 to 5 at a time. That's it. I mean, there's really, you don't have to get crazy. Jeff goes to the movies 2 to 5 times a week. You get the idea? Determine a value of k. So I did this one in class, but I'm happy to do it again here in the event that you're like checking this out after class or something and you're like, hey, how did this work? So determine the value of k for which this inequality has these solutions. So one of the reasons for doing this is to kind of make you think, what is this madness? And what I would encourage you to do is just look at the part that like seems familiar. Doesn't this part seem familiar? like x is between 0 and 4. So you don't have to freak out too much. And let's go back and start this thing out. So -1 is less than 3x minus k, which is less than 10, plus k. One reason I'm writing this is that k can easily blend in right here, and you just kind of ignore it. So what we're going to do is we're going to solve this for x, because, hey, we want basically to kind of look like that. All right, so I'm going to add k to each of the sides. Remember, you are allowed to do this differently than I would, and what that means is if you would rather like make this into 3 separate problems and go for it, but I like to do this, so here I go. So over here I get k minus 1 is less than 3x, which is less than 10 plus 2k, all right? I'm going to divide everything by 3, all right? And I could leave it like that, but I'm going to kind of put it into a fraction format. So it would look like this, 1/3 k minus 1/3. Take a moment to see if that makes sense to you. If it doesn't make sense, that is something we can discuss. Now, this thing right here, except for these being kind of ugly, looks exactly like that. 0 on the left, x in the middle, 4 on the right. And so what we're going to do is I'm going to stab the screen on accident, 1/3 k minus 1/3, and set it equal to 0. The idea is if this whole thing was 0 and this whole thing is 4, then we have that and we'd be happy. So now I'm going to pretend, okay, well this is making that equal 0. So I add 1/3 to both sides. I'm going to multiply by 3, and I get that k equals 1. So if k is 1, just by the way, let's plug it in right here and see what we get. 10 plus 2 times 1 over 3. Well, that would be 12 over 3, and that would be 4. So k must equal 1 in order to make this work. Let me know what questions you got.